So guys, as you can see, this is our LCD and these are the two buttons. Let me press this button. See, this moves the text to the left and this one moves the text to the right. It is like scrolling. So if you have a very long text, you can use this technique to scroll it so you can see more on it. So let me show you the code. So this over here is the code. As you can see, we have our LCD initialized here, LCD pins, then LCD initialized, then the two buttons initialized. Then we check if the button is pressed, and if it is pressed, we use this command to move it to the right, shift the LCD bits to the right. And if the other button is pressed, we shift the LCD bits to the left, and then we display whatever is on the LCD. So simple as that. And this whole scenario gives us this result, that we get the shifting of LCD. Simple as that. See, it is working like a charm. Hello guys, welcome to learning microcontrollers. In this video, I will show you how we can shift text left or right on 16x2 LM016 LCD using two push buttons using PIC16F877A microcontroller. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins in DIP variant, and this over here is a 16x2 LM016 LCD. And this is a potentiometer that we will need to connect this LCD with a PIC. This potentiometer will be used to adjust the contrast of this LCD. It's a 3-pin 10 kilo ohm variable potentiometer. Now guys, let's do the connection. First we connect the LCD, then we will connect the buttons. Now to connect the LCD, first of all, take a look at the body of this potentiometer. You can see that it has 3 pins labeled as 1, 2 and 3 like this. Now guys, for the LCD, if you hold it like this from left to right, it is like 1 to 16. Now pin number 1 and 5 of the LCD, you common them, then you common it with the pin number 1 of your potentiometer, then you send it to the common ground like this. Then guys, for the pin number 3 of the LCD, that is the adjustable contrast pin, connected to the pin number 2 of the potentiometer like this. Now guys, pin number 2 of the LCD, you connect it to the pin number 3 of the potentiometer. From there, you send it to the 5-volt supply, common supply of your PIC and your rest of the circuit like this. In this way, your LCD will get the 5 volt and your potentiometer will get the 5 volt. Now guys, for the pin number 4, it's a RS pin. You can connect it to any available digital input output pin of the PIC. I'm going to use the pin number 15 of the PIC, that is pin number C0 like this. Now guys, for the pin number 6 of the LCD, that is an enable pin. Again, you can use any available digital input output pin. I'm going to use the pin number C1. Now for the pin number 11 of the LCD, that is data pin 4, connected to any available digital input output pin of the PIC. I'm going to use the pin number C2 like this. Then for the pin number 12 of the LCD, connected to the pin number D2 of your PIC. Then guys, for pin number 13 of the LCD, that is data pin 6, I'm going to use the pin number D3 of the PIC like this. Then guys, for the pin number 14, that is data pin 7, I'm going to connect it to the pin number 23 of the PIC like this. That is pin number C4. Now guys, in this way, our LCD data pins are connected. Now guys, pin number 15 and 16 of the LCDs, they are for the LCD backlight. If your LCD have a backlight, only then you are going to connect these two pins, else you will not connect these two pins at all. So in my case, I do have an LCD. This LCD do have a backlight. So pin number 15 is a 5 volt for the backlight and 16 is a ground for the backlight like this. Just connected to the common 5 volt supply of the PIC like this. Now guys, for these 4 pins, pin number 7, 8, 9 and 10 of your LCD, just leave them floating. We are going to use this LCD in the 4-bit mode. If you want to use this LCD in the 8-bit mode, only then you are going to need these 4 pins. Now guys, this over here is our push button, and let me label the 2 pins as left one as a left and right one as a VCC. Here you can shuffle these 2 pins, like you can take the left one as the VCC, right one as L. That's fine. So this button, when it will be pressed, we will shift any text on the screen by 1 to the left. Now guys, this is the second button. I again label it left pin as a right and the right pin as a VCC. Now to connect these 2 buttons with a PIC, you will need 2 10 kilo ohm resistors, one 10 kilo ohm resistor for each button like this. Now guys, first of all, you common the VCC pins like this of your push buttons. Then guys, you send it to the common VCC supply of the PIC like this. Now guys, for the top button, connect the left pin to the one end of the 10 kilo ohm resistor like this. Now from the same pin, you will take out your output. You can connect it to any available digital input output pin of your PIC. I am going to use the pin number B1 like this. Now guys, from the other end of this 10 kilo ohm resistor, connected to the ground like this. In this way, our top button is connected. And the 10 kilo ohm resistor is at the grounding end. This means that whenever the button will be pressed, a 1 will be sent. And that's all. Now guys, for the bottom button, lower button, that is the right button, Connect the R pin to the one end of the 10 kilo ohm resistor like this. Now from the same pin you will take out your output. For the output you can use any available digital input output pin of the PIC. I am going to use a pin number B0 like this. Now from the other end of this 10 kilo ohm resistor, connected to the common ground like this. In this way our both buttons are connected and our LCD is connected. Now guys, whenever L button is pressed, whatever the text is on the screen, it will move one digit to the left. And when the right button is pressed, it will move one digit to the right. That's what we are going to program this circuit in a way to do. Now guys, let's get to our hardware. Let me introduce you to the hardware before we move on to the programming. So guys, this is our micro C for PIC. Let me zoom in so you guys can see better. As you can see, this is version 7.2.0. You can use a higher version as well. Higher is always better. Click on File, New Project. This window pops up. Click on Next. Write the name of the project. I write LCD text shifting tutorial using push buttons by LM Learning Microcontrollers. Simple as that. Now guys, this is the project folder. Wherever you want to create the files, select the microcontroller you are going to use. I'm going to use a PIC16F877A. And then the device clock. This is a crystal connected to the pin number 13 and 14 of your PIC. I have a 20 megahertz crystal over there, so I'm going to use a 20 value here like this. Now click on Next and Finish. Now guys, before you do anything else, first of all, save your work. Press Ctrl S and save. Now guys, first of all, we initialize LCD. For that, go to the right, expand the micro libraries, expand the system libraries, go down, click on this LCD. You check mark the LCD library, expand it, go inside it. Here you have this LCD init command, double click on it. This will lead you to this window. Here in the example, here you have these commands, copy them till here. Now guys, you paste it above the void main like this. Now guys, here you first of all, what you do is that you initialize your pins. For that, remember what we have done on the hardware. For the RS pin, he is using B4, but we are using C0. So make it C0. And for the EN pin, he is using B5 while we are using C1. So just change it to the C1. Now guys, for the D7 pin, data pin 7 pin, he is using C4. Oh sorry, B3. We are using C4. That's all. For the data pin 6, similarly, we have D3. For data pin 5, we have D2. And for the data pin 4, we have C2. So recheck C0, C1, C4, D3, D2, C2. Now this was for the pinout setting. Now this is for the directional setting. Do exactly the same. For the RS, it is C0. Again, for the E1, EN enable pin, it's C1. For the data pin 7, it is C4. For data pin 6, it is D3. For data pin 5, it is D2. For data pin 4, it is C2 like this. Now guys, we initialize our LCD. Again, go to the right, expand the LCD library, double click on this LCD init command, go down. Here you have this command, you copy it, paste it in the one-time loop like this. Now guys, give some initialization delay. It is not necessary, but I suggest you always give it. In this way, our LCD is now initialized. Now guys, before we do anything else, first of all, I would like to remove the cursor because usually there is a cursor on the screen by default. If you want to keep the cursor, you can keep it, but I would like to remove it. I don't like the cursor. So go to the right. Here you have this LCD CMD command. Double click on it. This will lead you to this window. Copy this command from here, LCD CMD, and you paste it below your initialization delay. Now this command clears the screen, but inside it, remove the LCD clear, go to the right, again expand the LCD CMD library. Here you have these available LCD commands. Here look for a command called turn off cursor, this command. Copy this green part, this is the command, copy it and paste it inside this bracket over here. Now this command will remove the cursor. Now guys, what I do is that I give some initialization delay, not necessary, but I suggest you always give it. Now guys, we have our LCD initialized and the cursor is removed. Now we clear the screen if there are any rack back values by default. So you go back, double click on this LCD CMD command. You copy this command LCD CMD LCD clear. Go back, paste it here like this. Now this command over here will clear the LCD of any value. Now guys, what I do is that we have two buttons which will be used to shift the characters to the left and right. So we initialize those buttons. So we have one button at pin number B0 and one button at pin number B1. So let me write this: B dot F0 equals to 1, and initially the button must be B dot F0 equals to 0. Why? Because our 10 kilo ohm resistor is at the grounding end. So that's why whenever the button is pressed, 1 will be sent. So by default it must be at 0. And this is just like pin mode command in Arduino. We have this command twist register here. It's a direction register. 1 means the pin has been declared as input and 0 means it's an output. Now give some initialization delay. Not necessary, but I always suggest you give it in the one time loop like this. Now this is for our, I call it the shift right button. Now we initialize the shift left button. So again paste it and make it left, and the next button is at pin B dot F1, that is pin number 34 like this. Now the second button is initialized, LCD is initialized. Now we go for our forever loop, write down while 1. Forever loop starts here and forever loop ends here, and inside it we write our code. Now what we do is that we first of all display some text on the screen. I write, just go to the right in the LCD library. You have this LCD out command, double click on it. Here you have this command in the example, you copy it, go back, paste it like this. Now LCD out, what start from start writing from the first row, first column, just write okay, I write LM, that is learning microcontroller. Okay, that's all. Now what we do is that we give some initialization delay, like sorry, not the initialization delay, this is a delay that like for 300 milliseconds it will be displayed on the screen. This will increase the smoothness. Now above this we check if the button is pressed. So if code B dot F0 double equals to 1, if the button at pin B dot F0 is pressed, then it will go inside this loop. But for that, before that, we do is that if the button is pressed, we make it again and we check it again. Now if the button is pressed and it is being pressed for more than, I make it like 50, like if the button is pressed and it is being pressed for more than 50 milliseconds, only then it is considered to be pressed. Why? Because this is a debouncing delay. These low quality buttons usually have some, because of some phenomena, like because of some electrostatic shock or because of some dust particle, there is a possibility that these buttons might get shorted, and shorting means it gets pressed. So whatever it is inside, it will initialize that task. So to save ourselves from such a scenario, we use a debouncing delay. Like if the button is pressed for more than 50 milliseconds, only then it is meant that a human has pressed the button. Only then it will be considered pressed. So simple as that. That's why I gave this delay. Now what I do is that if the button is pressed, we go to the right again. Now again, okay, first of all you take this command from here, LCD CMD, paste it here. Whatever is inside it, just remove it. Now again go to the right in the LCD CMD library. Here you have various commands. Look for a command called LCD shift right. This command over here, it will shift everything on the LCD to the right by 1. Now I paste it here like this. Now this way, if this button is pressed, the LCD will shift to the right by 1. Now for the second button, what I do is that I copy all this. Let me remove the delays. Just copy all this like this and make it else if. Else if the other button is pressed, then what should happen? Then it should move to the left. That is the other command, just replace the right with left. Now this will move it to the left and the button is B1 like this. Simple. Now guys, whenever we will use this, it will move this to the right or to the left by 1, but it will then come. So guys, this will simply, whenever, if this button is pressed, B dot F0, the button at B dot F0 is pressed, it will move 1 to the right. Whatever the text is on the screen, LM will be moved to the right by 1. And if the button at B1 is pressed, it will be moved to the left by 1. Simple as that. Now we go to our PIC16 programmer tool and we burn this into the microcontroller and see what happens. Click on File, Import hex file. This is the file we just created. So it is selected. Click on Write. Okay, the new code is being written. Let me get to the hardware to show you what's going to happen. Okay, let it write. Okay, it's written. Let me turn on the code. See that LM is at the leftmost because we started writing from the 1 1, first row, first column. Now I press the right button and see what happens. See, the code is moving to the right. With one push of a button, it moves to the right by 1. If you hold it, it keeps on moving to the right. Simple. See, now I move it to the left. Simple as that. Now I leave it. It will stop wherever it is. See, it is simple as that. So this has some good applications, like whenever you are using programming and you want to do some scrolling, etc. Then you will use this technique. It is like a scroll here. So you can write a long text and you can simply scroll it. So it is a very useful technique whenever you are dealing with a text and you want to display text on your LCD. So it is very simple to use as well. So guys, I hope you learned something from this video. If you have any questions, you can ask in the comment. I will share with you this micro C4 PIC code in the description of the video. So you can play with the code as you like. So guys, thank you very much for your time and we'll see you in the next video.